Hi and welcome to another Unity 5 tutorial on artificial intelligence. This time I'm going to show you how to find the closest waypoint. The idea for this tutorial came from Flo Vivi, who I was having a conversation or a text chat on YouTube with, and I thought it'd be easy just to put together a simple tutorial to show you how to do it. Now what I've got here is the same set of waypoints and the same character that I had in the other AI for pathfinding examples. This time though, I've taken off the chase script that was on there. Instead, we're going to write some new script. You can also see in the hierarchy that I have taken out the FPS player, so you're not actually walking around. We're just going to watch this skeleton move around the waypoints. The first thing we need to do is create a new C# script, and we'll call that find closest, and let's open that up, and into here I'll put this code and then I'll go through and explain what's happening. So it's quite short and most of it is still from the original chase code as far as setting up the waypoints and the animations. So we have an array at the top here of game objects, which is your waypoints. We then have our animator section. Then we're setting up our rotational speed and our speed of our character. I'm going to just make those private so I can change them quickly in the code. And I'll also just increase this while I'm here. Let's set the speed to 3 because he tends to lumber around the scene a bit. Accuracy we'll leave at 5 and the current waypoint we'll set to 0, so that's fine. Now in the start function, we've got our animator being set up so that we can set the animation on our skeleton, which still is walking that we had before for that trigger. And instead of setting the current waypoint to 0 at this point, we set it to find closest waypoint, which is now a function that returns the index of the closest waypoint that's in this array up here. So you dump all of your waypoints into there, and then this script is going to go through and find the one that's closest to your player. Now the way that it does it is simple. It loops through and tests the distance and then returns the one that's closest. So first of all, there's a line of code saying if the length of the waypoint array is 0, then we return -1. That means there's no waypoint set up, so there's no point in actually running this function whatsoever. Then we set the closest waypoint to be waypoint 0 because we have to start somewhere. And then we test for the distance. Actually, we don't test, we set the distance. So we work out the distance using vector3.distance between the character's current position and the position of waypoint 0. And we put that distance into this last dist variable. So let's say that it's like 10. So it's storing that the distance to waypoint 0 is 10. Okay, then we're going to loop through all of the rest of the waypoints. Notice in this for loop we actually start at waypoint 1. We don't need to test waypoint 0's distance because we've already done it up here. And then we go and get another distance. So we work out the distance between the character here and waypoint 1, which is the first one. Then we test if the last distance is greater than this distance, it must mean that waypoint 1 is closer to the character than waypoint 0. So we then update the closest to be I, which is the number in the loop. In this case, it would update to 1. In my if statement, I'm also testing that we're not setting the current waypoint or the closest to be the current waypoint, because of course the current waypoint will be the closest because that's the one the character is sitting on. So you don't want to calculate the distance to that and you want to ignore it. So that by the time you've looped through here, you've actually compared and grabbed hold of the waypoint that is the closest, and then we're returning it with the function down here. So initially in the start, this will get hold of the closest waypoint. Then next in the update function, it's pretty much the same code that was before in the chase function as far as setting the direction of the character to be a vector that is the waypoint's position minus the character's current position. And then we're doing a slurp on that rotation so that it turns around. And after that, we're pushing the character forward again with this translate, okay, just pushing along the z-axis. And then finally, we want to test if we've made it to that waypoint. Once the character makes it to that waypoint, it then needs to find the next closest waypoint. And so we've got if direction.magnitude is less than our accuracy of how close we should be, then current waypoint is updated to find the next closest waypoint. The nice thing about this direction that we calculate up here is that direction is a vector, and vectors don't just have a direction, they also have a length. So direction.magnitude is going to be exactly the same distance if we found the distance between our current position and our waypoint that we're heading towards. So this is doing the same thing as a distance function. Okay, so let's save that. Let's go back to Unity, and now we're going to attach it to our character, which is the skeleton. Once it's attached to the player, you've got your waypoints exposed in the inspector here, and you want to put all of your waypoints in there. Now, it's very laborious to go waypoint 1, waypoint 2, waypoint 3, drag them all across one by one. So rather than do that, you can lock the code that's on the skeleton, and then you can shift select all of your waypoints and drag and drop that onto the waypoints, and that will put all of them in there for you. Now, you can't be guaranteed that they will actually go in order. I've named mine like this, and if you go through the process of naming them, then you can be pretty sure when you drag and drop they will go in order if you want to do that for other waypoint calculations. Right, let's run this and have a look what happens. So this waypoint over here is going to be the closest, which he will go for first. And he does that. Then he goes for this one here. Now the accuracy is set to 5. That's why he seems quite far away from where he's going. He's also going around in a circle. First of all, let's just go back into our code and update this accuracy to 2. Save it and run again. Just want him to get a little bit closer. Okay, so here he goes. He's got a little bit closer, I guess, and then he's going to go to this one. Now, once he gets here, he's going to calculate where the next closest is. Now, obviously, the next closest will be where he just came from because of the calculation. And if you don't want him to go round and round like this in this case, then we also need to change the code a little bit to take note of which waypoints we've already visited. So if you're wanting to visit all of the waypoints in your set, then you're going to have to keep a track of where he's been before. Now this can easily be done by inserting a list. Back in the code at the top, we'll create a list, and I'll call it path. This list will be a checklist, I guess, and we'll put all of the waypoints into the list at the start, which we do in this function here. So after we've captured the animator, we'll put in a for loop that goes through and grabs each game object out of that waypoints array and dumps it into the path. The path is actually just transforms because that's all we need. So therefore we're putting the game's objects transform in there instead. Now when we go to find the closest, we're going to work on the paths in the list. When we go to find the closest, we're going to work off of this list instead of our array of waypoints. So in here, first of all, we're going to test that path dot count, count is the length of the list, is equal to 0. If it is, return -1. We're then going to modify everywhere it says waypoints in the code and refer to the path instead. So in this here, we'll call this path, and path has already got the transforms in it, so we don't need to mention the transform there. The same here, this will be path. We'll get rid of our transform. Again, this for loop is going to go around path.count instead. And the rest should be right, because the list is essentially an array, even though it's a bit fancier than a basic array, has more functionality, and it still has an index into it. That's why we can still get 0 and I, and we can refer to the index as the current waypoint index as well. Now down in the update function, again we're going to replace our waypoints with path and put the position in there. And then the step that's going to make him forget about that waypoint, like not go back to it, is if we remove it from the list. So we go path.remove, and we remove the path at the current waypoint. That will take it out of the list, and then when we go and run the find closest waypoint again, it can't get the one we've been to because it's not in the list anymore, and therefore he will have traveled around all of those points. So save that and let's have a look how it behaves. Now from our previous experience, we expect him to go here and then there. Let's see how the new algorithm works. So the paths are filled up, he's heading off towards this one, but this time he actually goes over there instead. And that's because the closest function actually didn't fire until he was standing there. So he was closer to that one at the time, and it's given us different behavior. So the distance between this waypoint and this waypoint must be very close to this one and this one. But now you can see that his behavior is that he will continue to wander around covering each waypoint in turn, and then when that path list becomes empty, it just refills up again. Okay, so that's it. I hope you found that interesting. If it's been helpful at all, if you'd like to support the YouTube channel, Holistic 3D, please visit my Patreon 3D site and consider subscribing. And don't forget to check out my full Unity courses on Udemy. Talk to you next time.